My name is Mary O'Brien and I'm a consultant at One Spatial, specialising in the FME product set. So today I wanted to give you some ideas about how FME can be used, and we're focusing in particular on the water industry. If you have any questions as we go along, then add them to the chat window and we can deal with them at the end. So here's what I'm planning to cover. It should be about 40 minutes or so. We'll start with an introduction to One Spatial and to FME for those of you that are not familiar with ourselves or with the software. And then we'll look at what FME can do and explain that using some examples. So we've got a bunch of examples here that will take up the bulk of the session. So I'll show you some ways that we've been working with customers in the water industry and hopefully leave you with some ideas of things that you can do with FME. So if you see something that sparks your interest and you'd like to know a little bit more, then feel free to get in touch with us, fme@onespatial.com, and we can pick up the conversation from there. So just a little background on us. One Spatial, we're a systems integrator. We've been around quite a while. So we have a bunch of offices around the globe with our headquarters here in the UK in Cambridge. We work with lots of customers, especially in utilities, transport and engineering, and all levels of government. And really it's all about the data. So we help customers manage their data and get the most from it. And in addition to our own tools, we work with a number of technology partners. And today I want to focus on one of those, so our partnership with Safe Software, the producers of FME. Safe Software, well, they've been around since the mid-90s and they're based in Vancouver on the west coast of Canada. So they have a network of partners across the globe and a very active user community. And here at One Spatial, we're a platinum partner of Safe Software. And we've been working with and reselling FME for quite a while. So we provide support for all of the FME products. We have a team of skilled FME people, so we can help you really with any FME related questions or problems you might have. We provide training, so both public and private courses. We provide support through our support portal and consultancy services on the FME product set. So if you're interested, or if you're having any problems getting started with FME, or with getting the most from your FME workflows, then please do get in touch with us at fme@onespatial.com and I'm sure we can help. Okay, so today we're going to focus on FME and how it can help you in the water industry. It's a hugely important sector. Water is one of our most important resources. It's essential for life and, well, you know the saying, water, water everywhere. So I think the same is true of data in this sector. There is oceans of data out there, all different kinds of data being generated and being used throughout the business. So you've got things like, of course, your pipe network and all the associated information around the flow of water. You've got environmental data like water quality, flood risk, strategic considerations like maybe predicting reservoir capacity. And of course, knowing where your customers are. So you've got customer records with addresses and billing information, maybe satisfaction surveys. You might have demographic data to help with marketing your products. And of course, there's typically lots of different parties involved. So lots of contractors, and you may need to supply and receive data to manage and maintain your services. And these are just some of the examples I could think of. I'm sure you can think of a lot more. But of course, all of this data comes from different data sources that use different systems and different applications. So typically, you've got lots of different data formats and different data schemas that you need to deal with too. And that's where FME can help you. So it's a really powerful tool for managing and manipulating your data. FME stands for Feature Manipulation Engine, and really that's the best way to think about it. It's a processing engine for your data that lets you convert data between hundreds of different formats. So if your data is stored in databases or flat files, it doesn't matter. FME can help get your data from A to B. It's also a fantastic data transformation tool. So it enables you to define logical processes to apply to your data in a very user-friendly workflow interface. And I mean all kinds of data transformations. So changing the schema of your data, calculating some data values, doing some geometric calculations, or integrating data from all different sources. FME can do it all. And not just once, these are repeatable workflows. So next time you need to do that same task, you simply rerun the FME workspace. It just really helps you automate your work life. And that's the message really. FME helps you connect, transform and automate your data. And there are a number of FME products to help you do this. So you've got FME Desktop, that's the main tool. It runs the processing engine on your local machine. And that's what we use to build our logical business processes to manage our data. And that's what we're using here today. Then we have FME Server, and that gives you the ability to run those same processes but scale them to the enterprise level, so with multiple engines processing data in parallel. And then we have FME Cloud, which gives you FME Server but from a hosted cloud environment, so without the overhead of infrastructure and maintenance. But it's the FME engine, the processing engine, that's common to them all. So when we build our data workflow in FME Desktop, like we'll do today, then that workflow can be applied to the other products as needed. Okay, so let's look at some examples where FME can work for you in the water industry. First up, well, we can use FME to pull data together from different sources. So let's say we have incidents being reported into our call center and that's stored as CSV files. And we've got customer database sitting in Oracle with our locations. And then maybe we've got some boundaries for water districts or operational areas, some areas that are of interest to us. And it's there as a shapefile. And we need to pull all that data together to be able to send, the right works team out on site or report on performance, whatever it is that we're trying to achieve. So here's what our data looks like. So you can see we've got a customer ID field that we can use to link the incidents to the customers. So a database join really. And then geometry that links the customer point locations to our reporting areas. So let's jump over to FME and take a look at how we might do it. So here I've got a blank FME workspace. I've got the desktop product, and I've just got myself some reminders on what we're going to do. So we want to pull that data together. So first of all, we need to read some of that data in. So I'm going to add some readers. So I'm choosing a reader. I specify the format. So here it's a CSV file. And I'm going to pick my incident CSV. Can choose the parameters and get a view of how it's interpreting that data. That looks okay to me. And that's it. Very simply, I've got my incidents data available to my workflow. The next data set, so the customer information, well, that's stored in an Oracle database. But again, I need to read that data in. So this time, my format is going to be an Oracle spatial object. And I'm choosing a database connection that stores all my settings. It's nice and secure. So it's looking in my demo schema and I'm picking up the customers table from there. So I'm adding that into my workflow. There we go. And I've got those two data sets now available to play with. And what do I want to do? Well, I want to merge these together. And remember we said we could join them based on the customer ID, so basically doing a simple database join. So to perform any of these tasks in FME, we use transformers. These are little bits of logic. And to search for them, I simply type on the screen. So you can see I've got a library of transformers here that do all different things. I'm going to choose this one, the feature joiner, and that's new for 2018. If you're an FME user, you're probably familiar with the feature merger, this transformer here. You could also use that in this case, but I'm going to choose the feature joiner because it's new, it's just available in the latest edition. So I'm going to pass my incidence data in, and I'm going to pass my customers data in. And then I need to specify the join. So I'm going to say join them where the customer ID matches the ID field. And this feature joiner gives you more options on how to specify the join here. So it's really like using a SQL join in a database. But it's also super fast, so that's the other great reason why you should check it out in FME 2018. Okay, so I'm going to connect an inspector here so I can see what's happening to my data at this point in the flow. So I'm going to run my process, and here I've got my output. So I'm getting the data output to the inspector where I've got the incidents joined to the customer information, and they've got locations. There are these points on the screen. So that's great. So that's worked a treat. Next thing we've got was that other data set about our operational areas. So that was our shapefile data. So if we want to pull that data into the workflow, we can again use our reader, this time point at an Esri shapefile, and choose the shapefile that we're interested in. There we go. This time we want to join the data or merge it together based on geometry. So we've got transformers that we can use for that too. So a bunch of different transformers you could use. The one I'm going to use is point on area overlayer. So we can see that performs a point in polygon analysis. So I'm going to pass the point data into the point port and the areas into the area port, and that will now perform the analysis of which points are in which areas and which areas are in which points and so on. But before I do that, I've got to ensure that my data is set up correctly. So I need to ensure that my data coming through here is in British National Grid. So I might need to reproject the data. Well, there's a transformer to do that. So I can simply add a reprojector transformer here, tell it to reproject it to British National Grid, and then both data sets will overlay in the correct locations. I can add a bunch of inspectors on here, run my process again, and now I can see I've got two outputs, but I've got, say, for example, the areas, and I can see in Oxfordshire I had 3 incidents, Buckinghamshire I've got none, Worcestershire I've got 3 incidents, and so on. So I'm merging the data together, pulling the best out of all of the different source data sets that I've got. So I could now go on to write this data out or go do other things with it. Okay, so as you know, a lot of the time we need to pull data together like this for reporting. So to understand our business or understand how we're performing, or to fulfill some regulatory obligations and so on. And so looking at the Water 2020 vision from Ofwat, Reporting on data and providing information assurance seems to be a really big theme. And customer service is key. So providing customers with a good experience is important. So being able to manage your resources efficiently and effectively is important to be able to achieve that. So having joined up systems, so for example, when a customer reports an incident, like a burst pipe, you can quickly prioritize and deploy a team to that location, or track the work in your work system and update the customer with an expected resolution time. That's just an example I was thinking of. But there's lots of them, and it's really all just data moving between different systems. But the better you can do it, so the more efficient your process is, the happier your customers will be, and the better your scoring will be with the different regulatory frameworks. So the more reward you're likely to get. And pulling data together from across your business and reporting on it to provide information that's easy to understand, that seems to be an important part of this. And well, as we've seen, FME can help us with pulling the data together. So let's complete that workflow we had by adding some reporting to it as well. So here we've got our workflow, and we're simply going to report some incidents in Excel, because well, everyone loves a spreadsheet, and it's nice and easy for everyone to use. And then we'll use the same workflow, so the same data, same workflow, but we're going to report also to a HTML file, so a web-based report. So if I go and open my workspace, and that's what I've got. So I had our process from earlier, and then over here I've got my reporting logic. So again, another thing that's new for 2018, I've got these collapsible bookmarks, which are really nice and neat. So as I expand them, I can then see all of the logic that I've built for this element. So here I'm going to write some data out to an Excel file, so I'm populating some of the data sheets, and importantly I'm using a template file here as part of the output. So I'm going to pour some data in, and it populates the template file. So that means when I run my output, I get a nice report like this using the template from Excel. So if you've got skills in Excel, then you can make this as pretty as you want. Okay, same data, same workflow, but here I'm going to produce a HTML report. So I'm writing out a HTML file here, and I'm using the HTML report generator. This is a really useful transformer if you want to create HTML output. So here I'm pouring some data into a table, and I'm pouring some data into a map, and these are the elements that are going to appear on my output report, and that's what it looks like here. So really quite simple, but a very effective web map report that's showing my incidents here on the map and also counts here on the table. Okay, next up, migrating data. So you can, of course, use FME to move your data between different systems. We've seen how easy it is to read data of different formats, manipulate it in different ways, and these are the classic elements of a data migration project. So whether it's manipulating your data to prepare it for a new application, or actually the source data you receive has changed schema, so its structure's changed, and you need to massage it to get it to fit into your existing applications. Or maybe you need to gather new or different information from your data because what you need to report to Ofwat or to your shareholders has changed. So there's lots of different scenarios for data migration, and FME is the tool to help you do it. It's one of the most common use cases for FME. And I guess it's often perhaps the project that FME gets purchased for. And you know, that's great, but there's so much more you can do with it now that you've got it. And it can help you add more value to your data holding. Okay, next example, processing a spreadsheet you get repeatedly. So in this case, the National Street Gazetteer. So the NSG, well, it contains the definitive information for streets in England and Wales. It's available to organisations with a statutory duty to coordinate street works, or basically anyone who typically digs up the road. And it contains information related to that, like which roads have restrictions at particular times of the day, or which roads are traffic sensitive or have height or width restrictions, and so on. It's managed by GeoPlace and it's updated monthly from data sourced from local authorities and highways authorities. And the data is supplied as CSV files, but it's really quite a complex structure. So the first column identifies the record type. So for example, type 11 are street records, type 13 are elementary street units, so ESUs, the street segments. And each of these has a different structure, so different columns of data, so we need to handle them differently. But they're all here in the same file with no column headers. And in fact, there are 2 files like this for every area. So you've got the LG file containing the street data, and the AD files that contain the additional data like special designations, and surface constructions, and so on. So it's going to be quite a complex job to manage the mapping of records to their correct table in the database. And remember, we get an update every month, so it's got to be automated and it's got to be easy for us to manage. And that's exactly what the schema mapper transformer in FME is designed to do. So we can store the schema mapping information in an external file. So here we've used Excel, as it's easy for everyone to understand, everyone can edit it. And here we've got the source structure, so the CSV files and their structure defined in the light colour, and then the required structure, so how we want it to map to the database, defined in the bright colours. And the colourings don't matter, they're just for demonstrating it here. So, for example, records with a call 0 value of 11 should have a call 3 value mapped to the USRN column of the street table, and so on as defined in our spreadsheet here. And then here in the schema mapper, we pointed at that file, the Excel file, and then we define the mapping like we've done here. Okay, well, let's take a look at what it looks like in FME. So here we go, we've got 2 sources, our CSV files, the LG file and the AD file being read in. Then we use the schema mapper to tag each record with the information about which table and which column it belongs to. We do a bunch of tidy up here, but essentially we're filtering the data here on each of those classes, so each of those feature types, the things that we are now familiar to us from the NSG, like streets and elementary street units and constructions and interests and so on. And then for each of those, we expose the attributes that are relevant to that particular class. Again, we do a bit of tidy up here before we write the data out to our database. So all different classes, all different tables in the database with the appropriate attributes assigned to each. And when we run the process, it loads the data to our database and it'll look a bit like this. And then next month, when we get a new drop of data, we can simply load the refresh to the database by running the same workspace. So in fact, all the complexity really is held in the schema mapping spreadsheet. And because that's stored in Excel, then it's easy for us to understand whether or not you're an FME user. And actually, in reality, it's kind of rarely as simple as that. So from working with customers, we know that there are always data issues that need to be dealt with, no matter what the data set. But FME can help you with that too. So some issues you might get are things like lines being encoded as polygons. And then you can use things like the geometry validator and geometry coercer transformers in FME to help you with that. If you get zero length lines and very short lines, then you could use transformers such as the line extender and the vertex creator to generate extra geometry. Or use some of the snapper transformers to snap lines to particular vertices. So really, you're using transformers to build your own workflow to enable you to identify what the issues are for you. And then you build your own business logic for how you want to deal with it. So for example, the additional street data in the NSG. It's a complex data problem. How would we represent multiple pieces of information for streets? Especially when there's multiple streets may have the same geographical location. So an ESU, a street segment, the thing here in red, that may form part of multiple streets. So like in this diagram, we read them as sitting on top of each other, being co-located. And then there may be different designations assigned to those streets. But the real problems start when those designations may apply to just part of the street. So what are termed partial streets? And that's typically defined as just start and end coordinates, because providing the geometry is optional in the data model. And when we introduce error or differences in how organizations have recorded this information, those start and end coordinates that we're relying on might not even intersect the street they relate to. They could be on a neighbouring street, or in fact they could be miles away. If you think of scenarios like moving a decimal point on a coordinate or switching X and Y coordinates, just very simple data errors that are very easy to make. So you can use FME transformers, to help you identify a bunch of these different scenarios and then build your own business logic using the transformers to deal with it. And these are just some of the transformers that you might want to look at for that. Okay, another example, another one in the theme of data processing. So let's imagine you have an ArcGIS Online service for managing roadworks. You might have a team of ground workers digging up the road, doing some maintenance work, and when they're finished, they take a picture with their Toughbook or their smartphone and they ship it back to the service as an attachment. Well, using FME, you can pull that data into your workflows and work with it. So the trick really is to expose the parameters relating to attachments on your ArcGIS Online reader inside FME, and then you have that data in your workflow to manipulate. You'll also need to use a raster replacer transformer if the attachment's an image, like a photograph, or an attribute file writer if it's a text file. Or if you've got skills in Python, then you can call a Python script using the Python caller transformer to do the work for you. So, you've got lots of options. And to expand on this a little, what if the data we need is provided by others as a service? So we don't need to process it in-house, we just need to consume it from their web service. So making requests to their API or their website. So we can use the HTTP caller transformer to do just that. So make a call to the data service and pull the data back. And the data we get back is typically in XML or JSON. So then we have transformers to help us manipulate that data too. So here's an example, consuming data from the roadworks.org open data site. It's the most comprehensive source of roadworks and traffic disruption information in the UK. So the data from over 2.5 million official roadworks notices per year are harvested in near real time, and then they're made available here for free. So that's an amazing resource. And they publish lots and lots of data. So you've got live traffic incidents, traffic restrictions, roadworks, public transport information, and operational information from the National Street Gazetteer. And if you dig around on their website, you'll find information on how the data web service can be called. So basically, it expects XML requests in the defined format. So once you've worked out your request, and if you've got a developer friend, this is where I'd get them to help you with it. But once you've worked out your request, you can simply use the HTTP caller transformer to send that request to the service. And you can see here we've used some XML transformers either end to manipulate it and format it correctly. So then we do some management of attributes and basically write it out to our database here. So next week or next month or the next day, whenever we need to refresh the data, we simply run the workspace again. It makes a fresh call to the service, gets us the latest data, and we process it. So really, that's really powerful. Another example, same idea, we're capturing data on weather observations from the Met Office data point site. And there's a wealth of data on here. It's available publicly to use under a fair use policy. So you can make up to 5,000 requests per day for free here. But again, it's an API, a REST API this time, and actually the documentation is pretty good. So even I could work out the request structure for this one. But there's lots and lots of data on here, so it's collected over time. It's lots of data that you could use for environmental modelling, maybe planning for water resources, all sorts of uses really. So let's go take a closer look. I'm going to go open the workspace. And here we have it. So we're starting with a creator transformer just to initiate the process, to kick it off. And then we're using a string concatenator to build the URL, so to build the requests that we're sending to the web service. So you can see here we're hitting the data point service at the Met Office, and then we're building our request string using a bunch of published parameters, so values that we can change at runtime. So for example here, we can specify which site and which frequency of data we're requesting from the data service. So we make the request with the HTTP caller, and then we have a bunch of transformers here just to help us manage the response and extract the bits that we want. And that's what we get here then. So in our output, we've got information on this particular site, Dunkswell Aerodrome, for today at all of these different time intervals and all the weather observations that are recorded there. So lots of information available and a really nice automated way of dealing with it. And now that we have the data, well, we could pull in other data sets like we did earlier, or we could maybe work out whether that site is in our area of interest, or we could test maybe the rainfall value, and if it's a really large value, so there's been heavy rainfall, then maybe we'd want to get an email notification into our inbox, something like that. So, there's transformers like the tester and the emailer that we can use in our workflow to do that. So there's really lots and lots of options. Okay, another example, more environmental data processing, but this time we want to use some specialist tools. So here we want to use the SAGA open source toolkit to do some pollution modelling of our catchment areas, for example. And here we're using Python scripts called SAGA, that's from FME, and then we have a couple of ways of doing it. So we can use scripts at the start of the FME workflow and again at the end once FME is finished. Or we can also use the Python caller transformer in the middle of our workflow to also make a call out to the SAGA toolkit. And that's essentially what we did. It looks fairly simple here, but actually there are Python scripts running that do all the work in the SAGA tool for us. So FME here is just one of the tools in use in the workflow in this case. So FME prepares the data for SAGA, then Python runs the SAGA tool, and then FME manages the output again so that it can be pushed to an Esri environment and then used in a GeoCortex workflow. So FME doesn't need to do everything. It can be the glue connecting different parts of your infrastructure and helping you get the most from your data. Another example, one with lots of uses, zipping up files. So getting a zip file at the end of your data processing. So this could be useful when you're supplying data to contractors for work areas, for example. So instead of zipping them manually with WinZip or 7-zip, then we call the zipping tool from the command line. And it's all done within FME. So here we go. Let's look at how we've done this. So very simple workspace. We've got a process that does some stuff. So we're reading in some data here and then we're writing it out. So it's very simple just to demonstrate it. So we're writing out a file here and we're using the feature writer transformer rather than a writer, so that instead of having to use a shutdown script, we can continue to build our process after we've written the file. So here we're using an attribute manager just to build the command line that we want to run, which is basically making a call to the zip program, so 7-zip or WinZip, and then it's the values that it's going to expect. And then we're passing that into the system caller transformer to run it on the command line essentially for us. So it's as simple as that. It's the system caller really that's doing the clever stuff and making the call out to the external tool from within our workflow. So it's really simple, but really effective. And so final example, well, really just building on the last one really. It's great that we've built a process to create data packages for contractors, the last example, but why not go one step further and make it self-service? So users can select the data they need and get the results right away. So no intervention needed, just a web connection. And that's where FME Server comes in. So the workflow we build can run automatically on a processing engine on server when a request is made to the FME Server API. And then it runs on the data download service and produces a zip file for the output, and that's delivered directly to the user's web browser as soon as it completes. So it's all automated, very light touch, so you really can get FME to automate your work life. And there's a link here, to this FME Server Playground where you can go see some demos and try it out. And if you're interested, please do come back to us. Well, that's it. Hopefully that's given you some food for thought. There are lots and lots of resources on the web, so please do go and check out the Safe Software website, and in particular their Knowledge Centre for articles, demos, lots of useful information on how to build your workflows with FME. Check out our OneSpatial website, onespatial.com/FME, for lots of information on the services we provide, case studies, links to previous webinars that might interest you, links to our training diary, and so on. And of course, please come to one of our FME World Tour events next month. It's free. You just need to register on the website. There's the link. It's a really great day with technical and customer presentations. And of course, there's lots of opportunities for networking and to ask us any questions if you have them. And generally, they really are great fun to So, register on our website if you haven't already, and we'd love to see you there. That's it from me for today. Thank you for your time and attention. I hope you found it useful, and if there are any questions, please post them and we can take a look, or feel free to email me afterwards. Thank you.